Good morning to all of you. Next topic is straight lines. We are familiar with two-dimensional coordinate geometry. It is a combination of algebra and geometry. In earlier classes, we studied coordinate axis, coordinate plane, plotting of points in a plane, distance between 2 points, section formula, etc. All these concepts are basics of coordinate geometry. We also studied some important formulae. They are first one, distance between two points P with coordinates x1, y1 and Q with coordinates x2, y2 is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Second one, coordinates of a point which divides the line segment joining the points with coordinates x1, y1 and x2, y2 in the ratio m is to n. Number 1, internally are mx2 plus nx1 divided by m plus n, comma, my2 plus ny1 divided by m plus n. Second one, externally are mx2 minus nx1 divided by m minus n, comma, my2 minus ny1 divided by m minus n. Third one, coordinates of midpoint of line segment joining the points with coordinates x1, y1 and x2, y2 are x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Fourth one, coordinates of a point which divides line segment joining points with coordinates x1, y1 and x2, y2 in the ratio k:1 or kx2 plus x1 divided by k plus 1, comma ky2 plus y1 divided by k plus 1. Fifth one, area of triangle with vertices x1, y1, x2, y2 and x3, y3 is 1 by 2 into modulus of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Slope of a line. A line in a coordinate plane forms two angles with the x-axis, which are supplementary. The angle theta made by the line L with positive direction of x-axis and measured anticlockwise is called the inclination of the line L. Definition. If theta is the inclination of a line L, then tan theta is called the slope or gradient of the line. Slope of the line is denoted by small letter m. Thus, tan theta is equal to m. What about the angle made by the line which is parallel to x-axis? 0 degree. What about tan 0? 0. Therefore, slope of line parallel to x-axis is 0. What about the angle made by the line parallel to y-axis with x-axis? That is 90 degree. What about tan 90 degree? Not defined. Therefore, slope of a line parallel to y-axis is not defined. Hence, slope of x-axis is 0 and slope of y-axis is not defined. Slope of a line when coordinates of any 2 points on the line are given. Let P x1 y1 and Q x2 y2 be the points on non-vertical line L whose inclination is theta. Draw Pn and Qm perpendicular to x-axis and PR perpendicular to QM as shown in figure 1. Since PR is perpendicular to QM, therefore angle QPR is equal to theta. Case 1. When theta is acute, tan theta is equal to QR divided by PR in triangle QRP. That is, tan theta we can take as m. M is equal to y2 minus y1 divided by x2 minus x1. Case 2. When theta is obtuse. In figure 2, angle QPR is equal to 180 degree minus theta. This implies theta is equal to 180 degree minus angle QPR implies tan theta is equal to tan of 180 degree minus angle QPR implies M is equal to minus tan of angle QPR is equal to minus what is tan of angle QPR? That is QR divided by PR is equal to minus QR is Y2 minus Y1 divided by PR is X1 minus X2. This implies M is equal to Y2 minus Y1 divided by X2 minus X1. Conditions for parallelism and perpendicularity of lines in terms of their slopes. Let L1 and L2 be non-vertical lines in a coordinate plane with inclinations alpha and beta respectively. Let M1 and M2 be the slopes. If L1 is parallel to L2, then alpha is equal to beta. This implies tan alpha is equal to tan beta, implies M1 is equal to M2. Conversely, let M1 is equal to M2 implies tan alpha is equal to tan beta, implies alpha is equal to beta. Therefore, L1 is parallel to L2. Hence, two lines are parallel if and only if their slopes are equal. If L1 is perpendicular to L2, then beta is equal to 90 degree plus alpha by using a exterior angle property. This implies tan beta is equal to tan 90 degree plus alpha. This implies tan beta is equal to, what about tan 90 plus alpha? Minus cot alpha implies tan beta is equal to minus 1 divided by tan alpha implies tan alpha into tan beta is equal to minus 1. This implies m1 into m2 is equal to minus 1. Conversely, let m1 into m2 is equal to minus 1. This implies m1 is equal to minus 1 by m2. Implies tan alpha is equal to minus 1 by tan beta is equal to minus cot beta. This is nothing but as a tan 90 degree plus beta or minus tan 90 degree minus beta, that is tan beta minus 90 degree. Therefore, alpha and beta differ by 90 degree. Therefore, L1 is perpendicular to L2. Hence, two lines are perpendicular if and only if product of their slopes is minus 1.